Hi everyone. So we're going to be talking about linear equation applications. Example 1 says many companies require employees to track fuel fill-ups and fuel economy in their older vehicles. A truck driver leaves a gas station with a full gas tank. The odometer reads 87,625 miles at the gas station. At the next gas station, it takes 33 gallons to fill the tank. At this next fill-up, the odometer reads 88,022 miles. Find the fuel economy for the truck. In other words, find the rate at which the truck uses a gallon of gas. Be sure to show your work and reasoning. Oftentimes, it is helpful to make an input-output table. And so let's think about what our input is and what our output is. The input will be the number of gallons of gas used. And so initially, there's no gas used, and we're just starting off on our trip. And the output will be the reading of the odometer in miles. And so the odometer starts off with 87,625 miles. Later, the truck fills up, and so we know that it ended up using 33 gallons of gas because that's how much it took up to fill the tank. And at that instance, the odometer read 88,022 miles. Now, the way that we are going to calculate the fuel efficiency is we want to know how many miles the truck can travel per gallon. And you might have seen this symbol before. It's a triangle and it's actually a Greek letter. It's called delta and it means the change in. So the way that we're going to calculate this is we're going to calculate the change in the distance over the change in the gallons. And essentially what we're doing here is this is just another way of calculating the slope because this would be modeled by a linear equation. So the way that we're going to do this is, and you might have seen this before as well, the slope formula m equals y2 minus y1 over x2 minus x1. This helps you find the average rate of change, the constant rate of change, or in other words, the slope. So I can label this one x1, this x2, this y1, and this y2. So if I use that formula that I've written up above, I would calculate the change in the distance, so 88,022 minus 87,625, and then divide that by 33 minus 0. And if I do that, I've gone ahead and I've plugged that into my calculator, so we get 397 miles over 33 gallons. And then if you simplify that, this tells us that we get 12.03 miles per gallon. If it's any point of reference, my old 2004 Toyota Corolla gets about 30 miles per gallon of gas. So the fuel efficiency on this truck is not that great in comparison to my car, but that is often the case with trucks. Example 2 says a cell phone company charges a fixed monthly fee plus a certain amount per minute used. In January, the total cost of 175 minutes was $62.50, while in February, the total cost for 325 minutes was $77.50. How much does each minute cost? Again, just like in the previous example, I think it would be useful to make an input-output table. So the input is going to be number of minutes used. And some of you might be thinking, Mr. Kwan, when do we know which one is the input and which one is the output? Don't forget in a previous video, we called this the independent variable, and this one the dependent variable. So if you think about it, dependent, um, the amount that you're going to be paying is dependent on the number of minutes used, not the other way around. So let's just call the output variable the total cost of your cell phone bill. So we have kind of two data points. We know that if you use 175 minutes, then the total cost will be $62.50. And if we used 325 minutes, then the total cost would be $77.50. So just like in the previous example, we can use the slope formula. So we know that slope, the constant rate of change, is equal to y2 minus y1 over x2 minus x1. So if we use that, we get m is equal to $77.50 minus $62.50 divided by 325 minutes minus 175 minutes. So that ends up coming to $15 for every 150 minutes. But if you throw that into your calculator and you simplify that, that is basically saying that it will cost you 10 cents for every 1 minute. So let's just write a little sentence that describes that. So each minute costs 10 cents. Okay, and we know that there is a fixed monthly cost, and we want to figure out what that is. And so let's use this first data point here. We know that if we spend 175 minutes, that we're going to have to pay $62.50. So if I am using 175 minutes and it's 10 cents per minute, if I multiply those two numbers together, we end up getting $17.50. Now, we know that the total cost is equal to the maybe like the cost of the minutes plus the fixed monthly cost. So if we fill in those values, the total cost was $62.50. The cost of the minutes used was $17.50. And the fixed monthly cost, I'm going to just put a question mark because that's the thing that we are trying to figure out that we don't know. So how do we solve an equation like this, a linear equation where there's one unknown variable? If it helps you, we could also think of this as x or some other variable, maybe, yeah, let's do x. So what we could do is we could subtract the 1750 from both sides. So that's just on the right-hand side, that just ends up being 0. So we're left with x. And 6250 minus 1750 is 45. So that means that the fixed monthly cost is $45. Now, how could we check that? Maybe let's say you're not 100% sure. Well, you could always use the second data point just to check that. So let me erase this part. Let's just double check that really quickly. So if I had 325 minutes times 10 cents per minute, that would be $32.50. Then if I added $45 to that, would that check off and give me $77.50? Let's see. So 50, 2 plus 5 is 7, and 3 plus 4 is 7. So it ends up being $77.50, which is what we have here. So those match. So I'm just going to put a little green check mark to indicate that that checks off.